We will wait for 5 minutes for everyone to come and then we'll start. It's okay. No problem. During the discussion, if you have any doubts, then you can put the message here. Then I will take on your doubts from here. Okay? It's okay. We'll wait for 5 minutes more for other students to join. After that, I will start the session. Okay, then I will start the class. Am I audible, Ganeshan? So, welcome everyone. Today at the live interactive session number one for the course Natural Gas Engineering. Today, my name is Ananya Mandal. I am the TA for this course, and I will be taking some sample problems based on assignment number one. So let's start with few sample questions which will be helpful for you for solving the questions for your assignment number 1. So first question is, a rate of dash percent is considered attractive for drilling holes during the search for natural gas. So the options are A 10, B 20, C 25 and D 30. So any idea what will be the answer for this question? Uh, Ganeshan, you can type the answer, or Abdul, if you want to tell, you can tell the answer. So this is the question. The rate of dash percent is considered attractive for drilling holes during the search for natural gas. So options are A 10, B 20, C 25 and D 30. Um, 30. Why are you saying 30? Like what? Why you consider 30 as the answer? Can you write a short explanation? And also, Abdul, am I audible?
Yes, audible.
Okay, so did you read the question? Do you know the answer for the question? Okay, so I will repeat the question is, a rate of what percentage is considered attractive for drilling holes during the search for natural gas? So we are only considering like what will be the basic for which we will consider, okay, we can here we can explore more. So according to that explanation, the answer will be 10% because uh, until the late 1970s, successful drilling was a hit and miss operation. That's why a rate of 10%, that is one good well and 9 dry holes for every 10 drill, was considered attractive. So the rate percentage means that how many wells are digged, according to that which well, how many well you get your oil. So that is what is called the rate for which is considered attractive for drilling hole during search for natural gas. So that was what this question meant. Okay. So answer here will be 10%. That also, sir, that I took that answer from sir's notes only. So here the answer is 10%. So now let's discuss question number 2. That is, solve by Newton-Raphson method up to 3 decimal places where the function given as x cube minus 3x minus 5 and the x lies between 2 and 3. So the options are A 2.4252, option B 2.2790, option C 2.3333 and option D 2.8966. So now Newton-Raphson method is solved by using this equation. So in this equation, n is like n we have to take as some initial value, and from that we will do iterations and do keep doing the iteration till it gets converged. So the function is given to us, that is fx equal to x cube minus 3x minus 5 and x is between 2 and 3. So the Newton-Raphson method equation says that the next iteration xn plus 1 will be equal to xn minus fxn divided by f dash xn, where f dash xn is the differentiation of the function fx, the first differentiation. So to get xn plus 1, we need to first write fx here, that is x in terms of xn cube minus 3xn minus 5 and differentiate this function fx and write x in terms of xn. That will be, as we differentiate it, it will be 3x square minus 3. So here it is becoming 3xn square minus 3. Now simplifying this equation, it will become this. So we got for xn, the next expression xn plus 1 is in this, can be found by this relation. Now the starting of the iteration should be from the minimum value. So supposed to be from 2 to 3, so the minimum value is 2. So we will consider x naught, that is initially it has to be 2. So if we take x naught as 2, we will get xn plus 1, that is x1, by using this equation. So in place of xn, we will put the value 2, and from that we will get the first iteration. Now we have to use this as xn, and from that we will get the next iteration, that will be xn plus 1. So for x1, next iteration xn plus 1, that is 1 plus 1 2. So by putting this value in terms of this xn, the next iteration x2 will be 2.2805. So we have to keep doing this. Whatever xn value you are getting, put that in this equation, and from that the next iteration value you will get till the values get converged. As you can see, x3 value is coming as 2.2790, and then x4 value is coming the same, that is 2.2790. So from here we can say this equation got converged, and once we reach the convergence, that is the answer. So the answer for this question will be 2.2790, that is option B. Okay, okay, Ganesham. Or you can check this video, it will be uploaded on YouTube also, you can study from that. So the next question is, match the points A, B, C and D with their correct names as shown in the figure. So you can see the figure here, which is a for more than one. If we have only one component, the pressure temperature graph is different. But if we have more than one components, the pressure temperature graph looks like this. Now here there are different points like A, B, C and D, which you have to tell what these points signify. So the options you have to match the alphabet A, B, C, D with which of these points are named as. Okay, so Abdul, you have any idea about this graph? Okay, the sir has taught this graph for finding the properties of what kind of reservoir we have, what kind of reservoir it is, whether it has gas or oil or the condensate. That all depends on this graph, which is a pressure temperature graph for multi components. So here, to know what all these points are known as, we need to know the few definitions, few terminologies which are important for understanding this graph. So first is a bubble point line. So bubble point line is the point at which the first bubble of gas comes out of the liquid. Okay, so here you can see bubble point curve. This is the bubble point curve. So here, any point you take on this curve will be when at that certain pressure, uh, at that certain pressure, that is the temperature at which the first bubble of a gas is formed out of liquid. Whereas second is dew point line, which is the point at which the first drop of liquid drops out of the gas. So this is the dew point curve. Here, at this point, at certain pressure, the temperature that we will get is the dew point temperature, and at that temperature, first drop of liquid forms out of the gas. Now comes critical point. So critical point, this is considered the critical point, which is known as, represents the condition where the properties of the liquid and gas are identical, and it is also said that above the critical point, a liquid and gas can never coexist. Then comes Crickenden term, the highest temperature on the saturation envelope, which is shown by this point. So this whole envelope, you can see this is the farthest point at the temperature line. This temperature axis, the last point of this envelope is known as the Crickenden point, And then Crickondon bar is the highest pressure on the saturation envelope. So this envelope, the highest pressure, highest point which is this, and the pressure at which this highest point is reached is Crickondon bar. Okay, so this is the definition. Then the two-phase region. Two-phase region is the region where the gas and liquid coexist. So this whole region, which is bounded by these curves, is the two-phase region. Retrograde region is a region where liquid condensate forms by lowering pressure or increasing temperature. So this is the part where it is known as retrograde region, which is very important for natural gas study, because this is the point where there is a sometimes inversion of inversion occurs, such that even when the gas is forming into liquid, sometimes the liquid vaporizes again in this region because the volume lines and the quality lines are curved here. Because of that, when you are decreasing in pressure, when you are decreasing in pressure, it should move towards it liquefies, but again as the quality line changes, sometimes the liquid little bit vaporizes, and that's why this region is very important when we are studying to find what kind of methodology should be required for extracting natural gas. So now all the points and quality lines, these are the internal lines, are the quality lines which show the liquid percentage which intersect with the critical point. So these are all the terms which are important and which will be required for studying the phase and properties of the natural gas, and according to that we will know what methodology should be used for extracting the natural gas. So now let's go back to the question. So in the question they have asked to name the points A, B, C and D. So when you compare this graph with this one, you can see A is the two-phase region. So option 2 is the two-phase region. C is the critical point. Option 4 is the critical point. D is the Crickondon bar. So that will be your option 1. And D is the Crickondon term. So that is option 3. So we will match these two A, B, C with 1, 2, 3, 4, and option C is the correct answer. Okay, any doubt in this one? Because I think this time assignment also you have a question based on this graph. So for solving that assignment question, you should know all the parts of this graph, as this graph is very important. Okay. Next question is the viscosity of natural gas can be estimated by using. So the options are A, Standing's correlation, B, Morhan's correlation, option C, Brill and Beck's correlation, and option D, Kobayashi Carr Kobayashi Burroughs correlation. Now this question may be a little difficult for you to answer, but uh, for answering this question, you should know what are all these correlation and what all these correlations are used for. So the first correlation they are talking about is the Standing's correlation. So the Standing correlation is used by the California oil, which contains equations for estimating bubble point pressure, solution gas oil ratio, and oil formation volume factor for California oils. So a 105 experimentally determined data points on 22 different oil gas mixtures from California were used in development of the correlation. So Standing correlation, if they talk about, is a correlation which is used for estimating the bubble point pressure, solution gas oil ratio, and oil formation volume factor. Next is the Marhan's correlation. So Al Marhan 1985 is a Saudi Arabian oil. So the correlation contains equation for estimating bubble point pressure, solution gas oil ratio, and oil formation volume factor for the Saudi Arabian oils. So these all correlation they have created according to their oil qualities to find out like bubble point pressure, solution gas oil ratio, and oil formation volumes. Next is the Brill and Beck's correlation. It is a multi-purpose correlation derived from laboratory data for vertical, horizontal, and inclined uphill downhill flow of gas water mixture. So Beck's and Brill is mostly used to determine the pressure that will be occurring when we have to extract the natural gas from the reservoir. Then finally comes the Carr-Kobayashi-Burroughs correlation. So it was developed. It is they developed a graphical correlation for estimating the viscosity of natural gas as a function of temperature, pressure, and gas gravity. So that will give you the answer of this question, that which of the correlation is used for estimating the viscosity of natural gas. So option D is the answer, which is Carr-Kobayashi-Burroughs correlation. Every Tuesday 6 to 8 is this live session. So are you talking about the problem solving live session or the classes? Classes are all video. This live sessions will be on every Tuesday 6 to 8. So here I will be solving some sample questions only. But as you have done the assignment, so if you have doubt in your assignments also, you can ask in this session. Okay, so like the current assignment, if you have done already and if you're stuck on some questions, we can discuss in this live session and it will be helpful for you to solve those questions. And also the sample question which I am taking, they are kindly related to the questions that are given to you in the assignment. So you can like take inspiration, like get idea from this live session sample problems and also can discuss after the sample problem. If you have any doubts, either in class or in your assignment, you can talk. We can discuss about that also. Okay. So the next question is question number 5, that select the incorrect statement. So options are option A, the critical temperature is the temperature above which the gas and liquid cannot coexist regardless of the pressure. Option B, the dew point is the temperature at which the first drop of liquid appears when the system is heated. Option C, Crickondon therm is the highest temperature at which the two phases can coexist. And option D, the bubble point is the temperature at which the first bubble appears when the system is heated. So, Abdul, as you are the only one here, can you read the question and can you give the answer? I will wait for you to read them and get it. You can write an answer in the messages or you can tell me the option which you think is the incorrect statement. As in the last question, we already discussed the graph. So from that graph, if you can tell, and graph and the definition of lot of the terms, if you can tell which of this is incorrect statement. Option C. No, Abdul, that will not be the correct answer. See, it is saying Crickondensum is the highest temperature at which the two phases can coexist. Okay. So, like I discussed previously, this is the point of Crickondensum. So, anything inside this envelope are in two phases. So that means this is the highest temperature. Even at this temperature, or these the two phases are coexisting. After the this point is when these two phases will not coexist. Only gas will be there. So this statement is correct. That Crickondensum is the highest temperature for the envelope where both of them exist. So the actual statement which is incorrect is option B. So here it's saying that the dew point is the temperature at which the first drop of liquid appears. Till here, this is a correct statement. But it says appears when the system is heated, which is the incorrect part. Okay, because dew point, the temperature at which first drop of liquid will appear. So this liquid will be formed from gases. Right. So for gases to form into liquid, we have to condense it, and condensation happens when the temperature is lower. So if you heat something, it will go from liquid to gas. But if you condense, if you decrease the temperature, then it will come from gas to liquid. So that's what happens in dew point, that the gas will turn into liquid and the first drop of liquid forming is known as the dew point. So here the system has to be cooled, then only we will get the dew point. So that is the point which is incorrect in this statement. Okay, and all the other statements are correct. So the next question is the gas to oil ratio of the oil well is, and the unit is SCF by STB. So sir has taught this in class in his lecture. So can you answer this question? Okay, so Abdul, this is the next question. So the gas to oil ratio of the oil well is. So this was taught in sir's class and in the lectures also. So can you give me an answer for this question? It's okay, Abdul. Can you see the screen now? This question. Do you know about gas to oil ratio? Okay, maybe there is network problem. So I will define. Okay, I will tell about it. So the gas to oil ratio is the ratio of the volume of gas produced and the unit as HCF, which is standard cubic feet, in a reservoir to the volume of oil produced, STB, standard tank barrel, at standard temperature and pressure. So whenever uh, to, we uh, according to the gas to oil ratio, we can say whether this reservoir is a gas well, condensate well, or an oil well. So, whenever you got a reservoir, you take out the sample, and during the separation, you can find the quantity in volume of the gas and the liquid. And the ratio of gas to this liquid will tell you whether this reservoir is a gas well, condensate well, or oil well. So, the range that is talked about is for the reservoir to be a gas well, the GOR ratio should be greater than 1 lakh. For it to be condensate well, it has to be less than 1 lakh, greater than 5,000, And for it to be an oil well, it has to be less than 5000 SCF by STB. Now, the question is asked the gas to oil ratio of the oil well is. So, you can see for oil well, GOR has to be less than 5000 SCF by STB. So, option C is the correct answer. So, next question is how much amount of heat is liberated for the complete combustion of 2 moles of methane? So the options are A 1782 kilojoule, option B 891 kilojoule, option C 1031 kilojoule, and option D 1000 kilojoule. So to find this answer, we should know what is the amount of heat actually liberated by methane. So whenever there is a combustion of methane occurs, this is the chemical reaction that takes place. This is the chemical reaction. Now, here you can see the reaction is CH4, which is gaseous, plus 2 oxygen in gaseous gives 1 mole of CO2 plus 2 moles of H2O and a gas and an energy of 891 kilojoule. Now, this energy you are getting only for 1 mole of CH4. Here in the question they have asked the heat that is liberated for complete combustion of 2 moles of methane. So if we are doing a complete combustion, that means there are no side reactions happening. That means side reactions such as sometimes carbon monoxide is also formed when you are burning your hydrocarbons. But here they are saying a complete combustion. That means see all the CH4 available will react with oxygen and form CO2. And along with that will give you the energy 891 kilojoule. For 1 mole it is 891. For 2 moles it will be multiplied by 2. So 891 multiplied by 2 will become 1782 kilojoule. So option A is the answer. So next question, question number 8 is that the iterative formula to find out the root of equation fx is equal to x to the power 4 plus 3x square minus 7 equal to 0 by the Newton-Raphson method is. So the iterative formula, we have to use the iterative formula to find out the root for this equation. So how can we do that? So according to the Newton-Raphson method, this is the equation for it for iteration of iteration of any function. Now the function is given to us, that is x to the power 4 plus 3x square minus 7. First we have to do we have to differentiate it. First differentiation of this function, that will give us 4x cube plus 6x. So that is this value. So first we have to use the function, then the differentiation of that function. Now these two are known to us. We have to find the iterative formula. For that we will write all these x values as xn. If we change the x values to xn and then we will equate this equation, then we will get an equation of xn plus 1 in terms of xn. So for finding the iterative formula, you have to consider the x as xn and then you will get a correlation of xn plus 1 with respect to x by using the Newton-Raphson method. So this is what you have to do here, and from that you will get the value of xn plus 1, that is 3xn to the power 4 plus 3xn to the power 2 plus 7 divided by 4xn to the power 3 plus 6xn. So this is the answer. This is the iterative formula for the given function. Any doubts? Okay. So the next question is question number 9, that the value of the integral L calculated using the trapezoidal rule is 16 with a step size of h equal to 1. For the following value of x and fx, find the value of a. So the integral is given to us. This is the integral, and for a step size of 1, we have a function that function is given, function is known to us, and from that we have to find the value of a. So that means if you integrate this fx from 0 to 4 with a gap of 1, so the value of fx that you are getting is these. But one of those values are missing. So let's see how to find that value. So the integration is given. So according to the trapezoidal rule, the integration value will be equal to this equation, h by 2 y1 plus yn plus 2 into y2 to yn minus 1. So this is the equation for a trapezoidal integration using trapezoidal rule. Now the value of this integration is known to us. This is 16. So if we keep left hand side equal to 16 and put the values for this equation. So that is half y1. So first value of function 1 plus yn. So last value of the function, that is 7 plus 7 plus 2 into all the other values of that function, that is 2.5, a and 5.5. So we got an equation. Now after equating this, you will finally get the value of a, which is coming out as 4. So here the answer for this question will be option B, 4. So you understand, this is a normal, like one data is missing. So you have to equate the right hand side with the left hand side by knowing the equation for the trapezoidal rule. And from that, as the final value of the whole integration that is given, that is 16, we can find out the missing value a, which is equal to 4. So last question is question number 10, that saturation envelope is enclosed by the dash and dash in the pressure temperature diagram. So it's again referring to the diagram of pressure temperature that is used for natural gas study, and also you can say for multi-component study. So the options are A, Crick-Condon bar and bubble point curve, option B, bubble point curve and dew point curve, option C, dew point curve and Crick-Condon third, and option D, Crick-Condon bar and Crick-Condon third. So which one of these options is the correct one? Which is the saturation envelope is enclosed by which of these two points? So you have to answer this question. So Abdul, can you answer this question? Is again related to okay, option D. Okay, so you're saying the saturation envelope is enclosed by the Crick-Condon bar and Crick-Condon third. Okay, so they are talking about enclosing. So enclosing occurs by curves, but Crick-Condon bar and Crick-Condon thumb are 2 points. Okay, so if you think about points, okay, these 2 points are the extreme of that envelope. But here they are saying what saturation envelope enclosed by what? So here enclosing of some portion will be done by 2 curves. So here the answer will be bubble point curve and dew point curve. As you can see, this whole thing is the saturation envelope. And they are saying what is enclosing it, what is covering it. But Crick-Condon bar and Crick-Condon thumb are just 2 points on this enclosure. The bubble point curve, which comes from here to critical point, and again from critical point we are getting till here by the dew point curve. So these 2 curves are what are enclosing the two-phase region. So that's why the answer here will be option B, bubble point curve and dew point curve. So they are used to enclose the saturation region here. Okay. So you have to understand in the question when they are asking about certain points or the region. So sometimes like what you answered was correct if they said what are the extreme points of the saturation envelope. But if they said what is enclosing the saturation envelope, that time we have to talk about the curves which are closing this envelope, that is bubble point curve and dew point curve. Okay. I hope I am clear. Did you understand that one, Abdul? Okay. So do you have any of your own doubts from class or from the current assignment? You can ask those also because my sample problems are over. This was the last question. Have you done the assignment one yet? Okay, you haven't seen the video classes. What is your course? Like, what are you doing? You are doing BTech,
Yes, ma'am. I'm doing B.Tech Chemical Engineering.
chemical engineering. From where?
Chennai Savita Engineering College
Where is it?
in Tamil Nadu,
Okay.
Chennai.
Okay. So I am actually also from chemical engineering.
Okay, ma'am.
So, so you haven't started the video lectures also for sir, from sir, right?
Yes, ma'am.
So why did you like take this course? What was your motivation? Like in chemical engineering, as much as I know, petroleum is not taught.
I take four more courses in NPTEL, ma'am.
What?
More than four courses I take in enroll NPTEL course.
Okay. Okay. So next class will be on 6 6 p.m. will be next class. So you will be giving the exam for this course, right?
Yes, ma'am.
Okay, so then you have to complete the assignments also. So next class you have assignment due like assignment 1 and 2 both are due by next
Yes,
Wednesday.
ma'am.
So you have to finish it. So next Tuesday I will discuss sample questions from assignment number 2. So if you have
Okay,
doubts
ma'am.
like from this assignment number 1 and 2 for your course, you can discuss them in the next class. We will if there are any doubts we can discuss and solve those. Okay.
Okay, ma'am.
Okay. So and also if there are any doubts from the class that sir is teaching that you want me to repeat or anything, you can tell me. I will prepare those also.
No doubts.
Okay. Okay. Thank you then. Come like next time the finish like try to do all the assignments so that if you have any doubts we can help with that.
Okay, ma'am.
So from my side sample problems are over. If you you can leave. I will be waiting for if other students join because the timing is from 6 to 8 so other people also join later. So if you want, you
Okay,
can leave. Uh,
okay,
from my side, it's over.
okay. Thank you.
Okay. Hello, Manoj.
Hello.
Yeah, so the session actually started at 6, and I already like discussed all the questions from 6 to 7. So,
Okay.
you have done the assignments, the assignment 1 and 2.
No, not yet.
Have you tried the questions at least from assignment 1?
No. I think due date is 7th of August. First
Yeah,
assignment.
yeah. So, today actually I discussed some sample problems related to assignment number 1. Okay.
Okay.
Have you seen the lectures, like first week lectures?
No, not yet. I thought we'll attend this. We'll get some idea about this. I mean, the first session.
Okay, so the thing how it will work is I am here only to assist you with the assignments. So I every week I will be taking some 9 to 10 sample questions which are related to that week's assignment. So like today I did for assignment 1. So 10 sample problems which are related to assignment number 1. Next Tuesday from 6 p.m. I will start the next session where I will take sample questions for assignment number 2. So these sample questions are related to the assignment that are given to you this session, and it will help you to understand the concepts that are important, and also uh, by attending these sessions you can also ask your doubts from your latest assignment or anything from the classes. For that, assisting you with that things I am here. Okay.
Okay. So,
Okay.
like today, first session. I mean, the lecture which have conducted or taken. Is there any link where I can see of? I mean, that offline videos.
Yeah, I will be uploading this on YouTube, and the NPTEL people will send you the link, the page where you can access all these YouTube videos. Okay.
Okay, that means the session which I mean 8 and the sample problems you taken today, I'll be able to see. Correct?
Yes. Or yeah, I think the NPTEL from NPTEL they will send you the link or the YouTube link to get to my channel. I will be uploading this tonight, and from tomorrow everybody will be able to access it. Maybe if NPTEL they might give you the link in few days. If you want, I can share it right now for that page so that by tonight or tomorrow, or maybe NPTEL will share in few days. Then you will be able to access.
No, I mean that is okay. I just meant to ask because I mean I have missed that. I thought it is up to 8 o'clock, so probably the others will join little late. Even I just came from office, so if
Okay.
I can get that link, at least I'll go through with that and we'll try to attend the assignment number 1.
Uh, okay. In messages
If you
maybe
can,
I can write the channel name, my YouTube channel name. By tonight I will upload, so you can go through that.
sure, sure.
So this is the link for the channel.
Okay,
Okay, so by tonight or early tomorrow morning, I will upload so you can check the discussion that
okay,
happened. Actually,
noted. Noted.
only two students were there, but I started at 6:05. So, if
Okay,
possible, come at 6 because mostly there
sure,
are 10
sure,
questions in 1 hour. It is over. So, or if you want,
sure,
I
sure.
can repeat the questions for you. if you want again, like have 1 hour session.
No, no, no. That's okay. That's okay. You have already taken. Now you are going to share the link. I'll go through with that. I mean, that's my problem. I cannot ask you to repeat again. And that too, if I'm when I'm alone, because if there could be a couple of more students, so I mean, that will be worthful for you to repeating the same session again.
Okay. Then you can by tonight I will upload. You can see.
Sure, sure. Hmm. So you said only two students have joined.
Yeah.
Okay.
But
Actually, the thing is that this session probably, if I mean, see, that's up to you because you have scheduled the slot of 6 to 8, and mostly, I mean, the if sometimes what happens, like I have seen around 300 or 400 students have enrolled for this course, but most of them, if they will be the working, so for them to come from office and attend these by 6 makes difficult because this is a time when people leave from office and they travel to home, so that is the inconvenient. if
actually,
uh,
with this
if this
time
is a
I
1 hour.
chose because my work overs at 6, and then I take the
Okay,
session. Then I can go to my hostel. It's like that's why I have
okay,
used this.
okay. Noted. I mean, but you can take this session from your hostel as well. I mean, that's not be mandatory
Yeah, but
to.
actually before I used to, but there had issues like that Wi-Fi issue and all happened in my
Okay, okay,
hostel.
okay, okay.
That's why I
Because
take it from my
what
lab.
happened, see, you are investing your time, and if you feel happy if more student will participate and join, even if those student will have certain queries and that will be resolved, so even that will give, see, any for any teacher, if more students are attending, so that teacher feel happy, okay, at least so many students I'm teaching and they are getting benefited by your session.
Yeah. And but this, I think this whole semester it will be this session only because we have to give the
Okay,
slot, and for the whole semester that same slot we
okay,
have to follow. So maybe
okay,
next time,
okay.
next semester when I will take some course, I will like consider this, that to have the classes from 7 so that others, those who have office can
Yes,
join.
yes.
Thank you for the suggestion.
Mhm. Yeah. Okay, thank you, and thank you for rejoining. Just I think you might have received the message that I have joined, so you have
Yeah, like
joined
I
to
know
the
that's
session.
why, but I thought that it's from 6 to 8, so I think I should stay at least till 7:30. What if somebody joins late?
Mm.
That's why I was waiting. So it's
Okay,
okay. So
okay,
if you have any doubts, like next class, maybe if you can join early, it's good. But even if you can't join, you can like write messages in this chat. Like those who can't like talk and interact, they are at least opening the video call and writing their inquiries in the messages. So maybe you can write your messages, and I will take those inquiries later in YouTube. You can go and check what I have replied or anything like that. You can do if you're not
fine,
able to
noted,
come at 6.
noted, noted.
Okay.
Okay, okay. So you are doing PhD.
Yeah.
Okay, in which subject?
I'm from chemical engineering course.
Okay, so you are doing. I mean, the natural gas. I mean, the same on
Uh,
same subject. You are doing
I
PhD.
work on like hydrogen gas system. So,
Okay,
but
then how
like
this natural gas and hydrogen both came
because
together?
there is a like a transportation of hydrogen. There is a
Okay,
system that we can blend the hydrogen with natural gas. So that's why
okay.
I have to study about the like how natural gas works, so that after
Mhm.
blending with hydrogen, how that will like the effects will be different. So according, that's why I got my interest in like natural gas transportation system and its engineering. That's why I took this course, and I
Okay,
like I studied myself this course, and now
okay.
do
But
like
it
teach
is
others.
based on the syllabus. I can understand this is mostly on the production of natural gas and
Yeah,
optimization of the production of the natural gas, not any blending of the hydrogen for
no,
the
no, no,
transportation.
not that,
Mm.
but still, like I should know the basics to go further.
Definitely, definitely, definitely. Mm.
Yeah, and also a lot of the like uh, chemical engineers can work in like they do work in petroleum and all. So having this knowledge also benefits.
Definitely. See, I mean, now in the market, there is a shortfall of the chemical engineers, especially in the offshores or in hydrogen sector, both the sector. In anywhere, if I'll say anywhere, the process engineers, there is a shortfall. I mean, the in entire market, EPC market.
So, where are you from? Like, where are you working?
Okay. See, as you mentioned, actually, I'm working in Mumbai, and that makes it becomes difficult to, I mean, in traveling Mumbai and joining any session. Like earlier, I was in Reliance Industries. Now I'm working for the L&T Hydrocarbon in the
Okay.
offshore, in the production of. I mean, the right now the job on which I'm working there is in Qatar. The exploration of, I mean, the this is, I'll say, compression of the natural gas,
Okay.
so that exporting that natural gas to onshore from offshore.
So you are
You
not in India. You're from like you're working
No,
in
no,
Qatar or you're in Mumbai.
no, I'm working in Mumbai. That my project is in Qatar.
Okay. Oops.
Okay. It's like because mostly these oil and gas fields are in Gulf. So
Yes.
it's like you may search on internet. There is a North Field Sustainability Program (NFPS) that is to maintain the sustainability of the natural gas in the this Ras Laffan area. So that is is almost 30 years project, divided into 9 programs, and each has value of around 4 to 5 billion USD. So just to, I mean, and earlier I was in the Reliance Industries in the petrochemical in the Jamnagar refinery, work
Hmm.
for the and there you might have heard of why I was started asking question, because in the last 2 years, before I recently have joined the LNT. Prior to that, I was for the 10 years I was in the Reliance Industries in the petrochemical refinery, and there in the last 2 years prior worked for the hydrogen, because you might have heard the Mukesh Ambani is establishing around the 4 mega gigafactories in the Jamnagar. So one was production of the hydrogen, because that is from the refinery, from hydrogen production unit. I mean, the generating and pressurizing and transporting, and for the, I will say, refueling in the tankers or the vehicles which is moving inside the refinery. So that was one of my project.
Wow. You have worked like I am only on the research field. You have worked in real life and all. Yeah, like, I
No,
feel like I have so much to learn from you.
no. See, when we work, see, in our, when you work in the research field, you focus on the, I mean, see, theoretically optimization the thing, but the in the practicality, see, we have to when we face the EPC. So here the feed, I mean, the what why I mentioned the process engineers, there is a shortfall, because the entire basis of any these kind of the project is defined by the process, yeah, and petrochemical engineers who decides the what will is the uh, overall concept of the program or any project. Hmm?
Hmm.
So even mine, my previous organization, Reliance Industries, I came to know, like earlier, there was one course conducted by IIT Bombay on hydrogen. Pratibha Patil, she has done on that. During that, there was one girl who was doing the some research on the this storage of hydrogen vessel. Yes.
Hmm.
So just I came to know, I mean, just we
Actually,
interacted, and
in
she said
our
that.
lab also we work on hydrogen pressure vessels and hydrogen tube propellers.
Yes. So, and she just shared her resume, and I've shared in my, and she's now working in the Reliance Industries R&D division as a senior technologist.
Okay. My senior is also in Reliance actually.
Okay.
She worked here in IT Kharagpur, my lab only. She's also working
Okay.
in Reliance.
Yeah, because they are expanding, they are doing multiple research for the production of the hydrogen, even on entire hydrogen value chain.
Hmm.
Yeah. So see, anyway, so but the hydrogen has a brighter future compared to right now what is happening. Considering the future will be the hydrogen based on the its properties and the
Yeah.
advantage what on environment will get. But the thing is that now there is a delay in going forward because of the whatever the Gulf countries or whomsoever the countries are having the resources like oil and gas. They wanted to explore the first and then let it get transferred to the hydrogen. Otherwise, what will happen? It will spoil their because anyway that is their value. If everything will get transmitted into the hydrogen, so then whatever the petroleum or oil, crude oils and gases which they are having, I mean that is of no value, and that's the reason
Some,
all.
anyway, even if we move toward hydrogen, that movement is very slow right now. So, fuel, the significance
Yeah.
of fossil will be there for next 50 years. It will be there. But I think the
Yeah,
transition is still very
of course,
slow.
it will take 30 years of transition, but by that time they need to get value. That's why I said now the Qatar field, Qatar Energy. I mean, and even in any Saudi Aramco, Qatar Energy, they are trying to whatever the explore or extract anything which is possible so that they can get value. Otherwise, what will happen if there is a certain competition? So automatically get energy. I mean, if I'm getting energy from the either natural gas or anything, so that get divided, and
Yeah.
that their dominance will not be as is it is as it is now.
Yeah.
Hmm. So, but that hydrogen, that is, I mean, I mean, see, even I was keen to. I mean, I came into L&T, then I started working on the other project, which is related offshore. But earlier, I was also interested in the hydrogen because I was working in the Reliance Industries for
Hmm.
the on last 2 years for the hydrogen job.
Yeah. Hydrogen, like, it's like a hot topic right now. That's why even here in IT Kharagpur, my
Yes,
guide is very much like forward with hydrogen technology. So we are working
yes,
on that.
yes. It's only thing is in India, there's a slow. I mean, in India, it's not started. It will take a time, but in other countries like there are a
Yeah,
couple of countries.
America and all, they have like reached like the all the four processes of like hydrogen from
Mhm.
production to utilization, everything they have reached. So we are like
Yes.
little bit we are going like started few projects like
Mhm.
buses and all, and in our lab we work on like the that compressed pressure like compressed pressure vessel for
Mhm.
hydrogen storage and all, and designing for different applications, and also pipeline and tube trailers for transportation of hydrogen. So we are working on that, optimizing
Okay.
using composites. So actual
Completely.
actual our lab is on composites and using
Okay.
this composite for hydrogen applications. So that is
So
our.
now you are in which year?
I'm
I mean,
finished
no,
third year,
oh,
starting fourth. So
okay. So when your PhD will get completed?
my next year, hopefully.
Oh, next year. Good. Okay.
Okay, sir. It was nice to meet you.
Huh?
Uh,
Yeah.
sir, can I get your contact details also so that
Yes, sure. It's a 77
no, can you write? Okay, can you give your mail ID?
Kumar
KUMAR.
dot
Huh?
Manoj MANOJ
Yes.
dot pal
Hmm?
at the rate gmail.com.
Thank you, sir. But sir, this interaction that we had, it is also recorded. It might go to YouTube. Do you have any problem with that? Because
No,
it
no,
is a
no
part
problem.
of my class.
No, no, no problem. See, it's like, see, it is all the discussion is on the subject and what is the viability of the topic in the future.
Yes, sir.
Yeah. Okay.
Thank you, sir.
Okay. Thank you.
Nice to meet you. It was very nice
Yeah,
to meet you.
same here. Same here.